What is going on, guys? Welcome to another amazing chemistry tutorial, and in this tutorial it's kind of a continuation. We're still going to be talking about ionic bonds, but lots of new information, I promise. It's going to be super fun. So I'm going to be talking about ionic compounds and some rules that we have to remember. The first rule is this: whenever we have an ionic bond, even though some of the elements may lose electrons and other elements may gain electrons, the overall compound has to remain neutral. The entire compound has to have an even number of protons and electrons still. So say in the last example where we had sodium. Now that sodium pretty much lost an electron, so we gave it a positive charge, +1 we'll say. Now we pretty much took that electron and we gave it to chlorine. So that chlorine had an overall -1 charge. Well, even though this sodium lost an electron and this chlorine lost an electron, if we take a look at the entire compound overall, sodium chloride, it would not have an uneven number of protons and electrons. So basically the entire compound still has an equal number of protons and electrons, so it has an overall 0 charge. So +1 plus -1 equals 0. We're good to go. So let's go ahead and take a look at another example of this, and let me go ahead and think of an element that, let's say we have magnesium. Now I'll write this down here. Magnesium has 2 valence electrons. It has 2 electrons that it can give away and be happy. Now bromine, which is the chemical symbol Br, it has 7 valence electrons. So basically we know that it's looking for 8. Bromine is always looking for 1 electron. So bromine's like, okay, magnesium, do you got an electron I can have? And magnesium's like, yeah, I actually have 2 of them. And he's like, no, I only want 1 of them. So what would happen if you combine a magnesium and bromine? Well, since the compound must remain neutral, you just can't write magnesium bromine, because then you're going to have 1 extra electron and the magnesium is not going to be happy. So what you would do is, like I said, since the compound must be neutral, bromine is basically gonna take 1 of these electrons, and then it's going to need an additional bromine to take the other one, and then with 2 bromines the magnesium can give them both away, and each of those bromine atoms is going to be able to accept 1 of those electrons happily. So the formula for this compound would have to be Mg Br2, and that's how you write chemical formulas. You write how many of each element is basically in the formula. So this would mean you have 2 bromines, and even though I didn't write Mg1, whenever you don't write the 1, it's implied. So just write Mg, which means 1 magnesium, and Br2, which means 2 bromines. Simple enough. So let me go ahead and show you an easier way to figure this out without me having to talk you guys through it every time. So this thing is called the crisscross rule, and it's an easy, simple way to figure out the formula of ionic compounds. So say we have the ion magnesium. Now remember I told you guys that magnesium has 2 electrons to give away. So if you write the ion, it would be +2, because whenever it gave away those 2 electrons, it would have 2 more protons than electrons, so it would have an overall +2 charge. Now technically this is called a cation, but we won't get into that for now. I'm probably just going to call them ions. Now bromine, on the other hand, it only needs 1 electron. So whenever it receives that electron, it's going to have 1 more electron than protons, so it's going to have a -1 charge, or in other words, an anion. Simple enough? Follow along so far? So here is how you do the simple crisscross rule. First, you write the formula of the ions, which is Mg +2, Br -1. Step number 2, you drop the charges completely. So it doesn't matter if this is positive or negative, or this is negative or positive. You drop them completely, so they're just superscripts. They're just numbers. Next, you go ahead and you bring the elements down. Mg, Br. And now you're saying, okay, so how do I know which number to write? Mg 8, Br 73? No. Here is where the crisscross rule comes into play. you take the first number and bring it down for the second element's subscript, so Br2. Now you take the second superscript and bring it down to the first element's subscript, so Mg1, and remember, whenever we have a 1, we don't write anything because a 1 is just implied. So we have Mg Br2. That is what you get whenever you combine magnesium and bromine. Simple enough. So just remember that whenever you have a 1, you don't write that 1 at all, you just leave it blank, and that's chemists know whenever you leave something blank that a 1 is implied. So let me go ahead and, without all this crap on my screen, I'll show you guys one more example. So let's say, let me think of something good. Alright, I just thought of it. And that's embarrassing. So say we have some aluminum. Now aluminum can combine with chlorine, and whenever this happens, the aluminum is going to lose 3 electrons. So that's why we write aluminum plus 3. It has 3 electrons to give away. Now the chlorine, if you remember from the sodium chloride tutorial in the last one, chlorine only needs 1 electron because it has 7 valence electrons already. It only needs 1 electron to fill its energy level. So whenever it gains an electron, we're going to go ahead and write minus 1 because it has 1 additional electron. Simple enough. So now let's go ahead and do the crisscross rule. We go ahead and bring down an element, which is Al, and also Cl for aluminum and chlorine, and now we crisscross it. So we bring this 1 down here, and we don't write it. Well, we can go ahead and write it for right now. And we'll go ahead and bring the 3 down, crisscross them. You see that little crisscross maneuver right there? Pretty good, I might add. Cl3. So we have Al1 Cl3, and that's the formula for this compound. However, if you remember, we don't write the 1, so it's AlCl3. And that is the final formula and basically the basics behind the crisscross rule. So again, to recap one last time, since each chlorine only needs 1 electron to complete its valence energy level, well, aluminum has 3 electrons that it can give away. So you can't just combine Al with Cl, or else you're going to have some more electrons left over, and we don't want that. So basically, every time you combine aluminum and chlorine, you need 3 chlorine atoms and 1 aluminum atom, and that makes everything happy, balanced, and neutral. So those are the basics behind ionic bonding, ionic compounds, and the crisscross rule. So hopefully with all my mumbo jumbo I didn't lose you, and you understand why you need more of an element sometimes to balance it out. And here's a simple way that you can figure that out without doing a lot of brain power thinking. So anyways, thank you guys for watching. Don't forget to subscribe. Don't forget to add me on Google+, and I will see you guys in the next tutorial.